Hey Algebra 1 students, it is Saturday night, almost 9 o'clock, and I'm here in my classroom making a video. I am working this weekend on getting more feedback to you for the homework that was from last week. I've already done the worksheet 6.3 part 1. I'm getting ready to work on properties of exponents. Some of you guys have already turned in your exponent packet review that's technically due on Monday, so if you have, that's great. I might not get it done this weekend. I might wait till everybody gets it to me on Monday. Please remember, showing your work is so important because that's how I can give you feedback and that's how I give you credit for doing the work. Also remember, as I'm sending you those emails with feedback for corrections, when you send that to me, your grade goes up. So you can earn a 100 even if the first time you didn't, but you got to send me back the correction so that I can change the grade in my paper grade book. I haven't gotten anything yet on RenWeb. I got to be honest with you, I'm a little overwhelmed. This whole thing is a lot more difficult than I thought. Not necessarily the video making, but the grading based on emails is driving me nuts. I like to hold a paper copy. I like to be able to write on it. Now I'm having to write on paper and then type it in an email so that when you email it back to me, I know what corrections I told you to make, and that's what I'm looking for. It's just very overwhelming, but we will get through this together. I'm gonna go ahead and get started on 8.4, where we are talking about what's called scientific notation, and you might have done this, you probably did this in pre-algebra, so this might not be brand new. I hope not. I hope that it's just a review. Here you just have a couple of facts, but the whole idea behind scientific notation is we are trying to take either really big or really small numbers and find a different way to write it. You don't want to write a number that has 21 zeros. You just don't. So we find a different way to write it, and that's through using scientific notation. So there are a couple of rules about scientific notation, and hopefully you're following along on the notes that you've got in the blank copy. It says scientific notation is a shorter method for writing very large or very small numbers. Here they give us an example of what the number 93 million would look like in scientific notation. So it kind of walks us through the process. And here's what it tells us. It tells us that this first number, we're calling it the constant. Remember, constant just means a number that doesn't have a variable. The constant has to be a number that's greater than or equal to 1, so it can't be smaller than 1. It can be 1, or it can be bigger than 1, okay? And it has to be less than 10, all right? So it can be 1 or bigger, but it can't be 10 or higher. So that number right there, 9.3, is perfect. It's bigger than 1, it's less than 10. Then it says that the power, that means the exponent, and the exponent is always going to be on a base of 10. That number that's the base of 10 is not going to change. That 10 will always be a 10. It says the power is always written with a base of 10, and an exponent is simply going to express the number of places that the decimal point has been moved. Now here's a common mistake that I see from students. Some students think that that exponent represents how many zeros you're going to add onto your problem, and that is not the case. You are only going to use that exponent to determine how many times you're going to move the decimal point. So if we take a look at this number right here, we have 93 million. You'll notice that it doesn't currently have a decimal point. So if a number doesn't have a decimal point right now, that means it's understood to be at the end. Now they have placed the decimal point in between the 9 and the 3, because remember that first number needs to be 1 or bigger, but it can't be 10 or higher. So they put it right there in between the 9 and the 3. That means that the decimal point was moved 1, 2, 3, 4, 5, 6, 7 times, and that's why the exponent was a 7, because it was moved 7 times. All right, well, a couple of ideas about those exponents. If your exponent is a positive number, that means that your number is a big number. And the way I define a big number is that it is bigger than 1. If your exponent is negative, it doesn't mean that your answer is negative. It just means that your number is going to be a small number and I'm defining that as a number that's less than 1. So that's what I have right here. Big numbers have an exponent that's positive. Big means bigger than 1. All right? Small numbers have an exponent that is negative. So small numbers are smaller than 1. So they gave us a couple of examples. 62,500 is going to have a positive exponent because this is a number that's bigger than 1. This number, so 0.0247, now if you were going to read this number correctly, this is the tenths, the hundredths, the thousandths, the ten thousandths. So that would be 247 10,000ths. It has a negative exponent because this is a number that's smaller than 1. Again, notice the first numbers on both of these. They're in between 1 and 10. And that's where they have to be every single time. All right, so we're going to practice writing these numbers in scientific notation. So let's look at number 1. We have the number 256 million. Where do you think the decimal point needs to go if we need that first number to be 1 or bigger, but smaller than 10? Well, it needs to go right here, in between the 2 and the 5. So we're going to have 2.56. Now, once you get to the point where you have nothing but zeros, you don't have to write all those zeros. You can just leave it as 2.56. I don't need to write all of the zeros that come after that. You can, but it's unnecessary. Now, where is the decimal point in the original problem? Well, remember, if you don't see one, it's at the end. So we have moved it 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm going to have 2.56 times 10 to the 8th power. Remember, that's going to be a positive 8 because my original number is bigger than 1, and that means I need a positive exponent. So over here, we have 0.0036. I see the decimal point this time. Where does my decimal point need to be so that my number is in between 1 and 10? We're going to put it right here in between the 3 and the 6. We're going to get 3.6. That's a great number. That's bigger than 1. It's smaller than 10. Now this time I already know that my exponent needs to be negative. Why does it need to be negative? Well, because my original number is less than 1, and so that calls for a negative exponent. So the decimal point was here, but we have moved it 1, 2, 3 spaces, and we're going to make that a negative 3 because of the fact that it was a number that was smaller than 1. All right, so let's try number 3. Where do you guys think that that decimal point needs to go? It needs to go right here in between the 6 and the 8. So I'm going to write 6.8092. Again, I don't need to write the remaining digits because they're all zeros. Times 10 to the, now I need to figure out my exponent. Well, my decimal point was at the end. I've moved it 1, 2, 3, 4, 5, 6, 7 times. And because my number is bigger than 1, it's going to be a positive 7. All right, number 4. I see my decimal point. Where do you think the decimal point needs to go so that my constant is in between 1 and 10? It needs to go right here in between the first 2 4s. So I'm going to have 4.44. So I have a number, a constant, that's bigger than 1 and smaller than 10. I already know that my exponent is going to be negative because my original number is smaller than 1. And I only had to move the decimal point just one place, and so that's going to be a negative 1. So I'm going to encourage you, pause the video, do 5, 6, 7, 8, 9, and 10, and then pick back up with me and check our answers. Pausing. Okay, I'm coming back. I'm going to go ahead and get started with these answers. So for number 5, we would have 9.08 times 10 to the 4th power. Again, it's a positive 4 because I have a big number that's bigger than 1, and the decimal point was moved 4 places. For number 6, I'm going to have 5.89 times 10 to the negative 1, 2, 3, 4, 5, but a negative 5 because my number was less than 1 to begin with. Number 7, I'm going to have 1.3685. Again, I'm not going to need to write all of those zeros after it. Times 10 to the, I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9 times, and it's going to be a positive 9 because our number was larger than 1. Number 8, I'm going to have 2.7 times 10 to the negative 1, 2, 3, 4. Again, it's negative because I started with a very small number. All right, over here I'm going to have 6.74 times 10 to the 5th power. And then this last one, I'm going to have 7.0707. Again, I don't need the last two digits that are both zeros. Times 10 to the negative 2. I moved it over only 2 places, and it's negative because I started with a very small number. So hopefully you did okay on those. All right, so some questions to think about. It says, how do you know that a number written in scientific notation will be really big or a really small number? Well, remember what we talked about. We said if it's a big number, your exponent is positive. And if it's a small number, your exponent is negative. So really big numbers have positive exponents, and really small numbers have negative exponents. All right, it says, when do you write a negative exponent when converting to scientific notation? Well, remember that means it's a really small number. So if your number is less than 1, so number is less than 1. Doesn't mean that it's a negative number, just means that it's smaller than 1. When do you write a positive exponent when converting to scientific notation? Remember we said this is when your number is more than 1. So if you can get these ideas in your head, this section is really going to be easy. All right, so here we're going to do the opposite. We're going to be given something that's already in scientific notation, and we're going to turn it back into what we call standard form. So it says changing from scientific notation to decimal form. You can call it decimal form or standard form. Textbooks call it both. So I just want you to be aware that you could call it either one, decimal form or standard form. It says when the exponent is positive. So remember, if your exponent is positive, that means your number needs to be big. Things are big when your decimal point moves to the right. It gives you a big number. When your exponent is negative, remember that means that your number needs to be really small. Things get small when your decimal point moves to the left. Another way you can remember that, remember your number line. Your big numbers are to the right because they're positive. Your small numbers are to the left, they're negative. So that positive exponent tells you you're going to go to the right, and the negative exponent tells you that you're going to move it to the left. Now remember, the exponent doesn't tell you how many zeros you're going to add. The exponent just tells you how many times you're going to move your decimal point. Please don't confuse those two. So number 11, we have a positive 5 exponent. So we are going to move it right 5 times. So here it is right here. I'm going to move it over 1, 2, 3, 4, 5. You're going to see that I've noticed, I don't know what I just said. When I moved it 2 times, that already took it past the 8 and the 3. What happens to these other spaces? That's where we're going to add zeros. So it takes that number and turns it into 283,000. So it took that decimal point, moved it past the 8 and the 3, that was 2 times, then moved it 3 more times, which is why we're adding 3 zeros. All right, this one has a negative exponent. That means I should get a small number, so I'm going to move it to the left 3 times. So I'm going to take my decimal point. I'm going to move it 1, 2, 3. Now as I move it 3 times, you'll notice there's 2 empty spaces right there. I've got to fill those with zeros. So I'm going to get 0.00123, which looks great because my number is small. It's less than 1. And so that's what a negative exponent does. It gets you a number that is less than 1. All right, so I'm going to encourage you, pause it, try these 6 on your own. Hopefully you are pausing. And I'm going to pick back up here. So number 13 had 10 to the 0 power. What do you think is going to happen if your exponent is 0? Which way do you move it? How many times do you move it? Well, 0 means you're not going to move it at all. So you're just going to have 5.6. Another way to look at that, remember, we've been dealing with exponent properties in this chapter. 10 to the 0 is really just a value of 1 when you raise something to the 0 power. So what you have is 5.6 times 1, which is just 5.6. So a 0 exponent, you don't move it at all. This one has a positive 4, so we're going to take 4.9 and we're going to move it over 4 times to the right. So 1, 2, 3, 4. That means I need to add in some zeros. So my answer is going to be 49,000. All right, this next one we have 1.045. We have a positive 7 exponent. Again, we're going to go to the right 7 times. 1, 2, 3, 4, 5, 6, 7. That means I have 4 empty spaces that I'm going to add with zeros. So I get 1,045,000. No. Oh, no. Sorry. It's late. I'm sorry, y'all. 10,450,000. Got to make sure you got the right amount of zeros. All right, this next one, we have the number 8, and our exponent is a -1. So we're going to move our decimal point to the left. Now, you notice you don't see a decimal point. No big deal. It's behind the 8. We're going to move it to the left only 1 time, and we're going to turn that into 0.8. So we got a small number. Makes sense because our exponent was negative. All right, this next one we have 9.2, and we have an exponent of a -8. Again, we're going to go to the left 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. That means I'm going to be adding in how many? 1, 2, 3, 4, 5, 6, 7 zeros. So I've got 0.000000092. Hopefully you can kind of see why we like scientific notation, because it gets old drawing all those zeros and then you forget how many you've written on your paper and then you've messed up. All right, last one on this slide. We have the number 8.4. We have an exponent of a -6. We're going to go to the left 6 times. 1, 2, 3, 4, 5, 6. That means I have 5 empty slots where I'm going to put in zeros. So I have 0.0000084 is our final answer. Hopefully you did okay on those. Let's keep going. All right, evaluating expressions in scientific notation. So here's where we're going to kind of combine what we learned in the last couple of sections to what we're doing here. You have some options. You could go ahead and turn that into a number in decimal or standard form, same thing here, and then multiply those together. But I would encourage you maybe not to do that. So I'm going to regroup. Remember at the beginning of the year we learned about the associative property, which says that you can regroup things when you are multiplying. It doesn't matter how you multiply them, you're going to come up with the same answer. So in one group, I'm going to put the constant. So I have 1.4 times 7.6. And then in a separate group is where I'm going to put those numbers that have a base of 10. So I have 10 to the 4th power times 10 to the 5th power. All right, I need to work on this first set of parentheses. 1.4 times 7.6. So let me do a little bit of math. I'm going to get 10.64. So 10.64. How's everybody doing? Just did a little bit of multiplication. Here's where we're going to take a look at what we did at the beginning of the chapter, our exponent rules. So these have the same base. Remember we learned if they have the same base and we're multiplying, we're going to add our exponents. So we're going to end up with 10 to the 9th power because we added the 4 and the 5. So we have 10.64 times 10 to the 9th power. Now here's the problem. This number is not in scientific notation. It looks good and it looks like it's in scientific notation, but remember that your constant needs to be 1 or bigger, but it can't be bigger than 10. It has to be smaller than 10. So right now I'm kind of ignoring the 10 to the 9th. He's still there, but I'm going to ignore him, and I'm going to focus on this number right here. Where do you think my decimal point should go? It should go right there in between the 1 and the 0. So I'm going to turn that into 1.064. Now, do you think that the exponent here should be positive or negative? Look at the number that we started with, 10.64. In other words, is that original number bigger than 1 or smaller than 1? It's bigger than 1. So I'm going to have a positive exponent. And I only moved it one space. So I'm going to turn that into 10 to the first power. Moved it one space, and it's a positive 1 exponent because the number that we started with is bigger than 1. So now I'm going to take, again, go back to those rules that we've been talking about. These have the same base. What do we get to do if we're multiplying and they have the same base? Remember, we keep the base, we add the exponents. 1 plus 9 is 10, and so we end up with 1.064 times 10 to the 10th power. That's going to be our final answer. So let me just talk through it again real quick. First, I did regrouping with the associative property, multiplied those. These had the same base. Keep the base, add your exponents. Then this number was not in scientific notation, so I had to get it into scientific notation. And then once I did that, again, these have the same base. Keep the base, add the exponents, and now you're good to go. All right, I want you to try that one on your own, and then you can check the notes on my website and check your answer. I'm going to go ahead and move on to this one. So here, instead of multiplying, we have a fraction bar, which means we're going to divide. Again, I'm going to use that same idea of regrouping things. So I'm going to split these up. I have this constant divided by this constant. And then I have 10 to the negative first power divided by 10 to the negative fourth power. So I'm going to divide these two. So I have 1.2 divided by 4.8. So you know, with decimals, you can't divide if there's this decimal point here, so I'm going to move this over, which means I have to move this over. 48 cannot go into 12 at all, so I've got my decimal point. I'm going to move it up, add a 0. 48 goes into 120 twice. That is 96. That gives us a remainder of 24. Add a 0, bring it down. 48 goes into 240 exactly 5 times. So this has just turned into 0.25. So all we've done there is just a little bit of division. Let's talk about this. This comes back from the properties that we learned about exponents. If your base is the same and you're dividing, remember we learned we can subtract the exponents. Now I'm actually going to write this step down because here's what I want you to notice. I've got 10 to the negative 1 minus negative 4. I'm subtracting my exponents. But what's going to happen when I have those two negative signs? You might remember that it's going to turn into a plus. So what I really have right there, that turns into 10 to the third power because negative 1 plus 4 is 3. And up here I still have 0.25. But we have an issue because 0.25 is not in scientific notation. Remember, it needs to be 1 or higher. And this number is too small. It is smaller than 1. So for right now, I'm going to ignore the 10 to the third power. It's still there. And I'm going to focus my attention on that 0.25. Where do you think the decimal point needs to go? Well, it needs to go right there in between the 2 and the 5. And what kind of exponent are we going to have? Remember that original number, 0.25, it's small. It's smaller than 1. I should have a negative exponent. And I only moved it one time, so that is going to be a negative 1. So I end up with 2.5 times. Here's where I want to look at those two together. I'm multiplying. They have the same base. Here's where I want to add my exponents. So negative 1 plus 3 gives me 10 to the second power. So there's my final answer, written correctly in scientific notation. I'm going to encourage you, try this one on your own, and then check my notes on the website so that you can check your answer. And I'm going to go ahead and move to this last example here that I'm going to go over with you. So we've talked about having that outside exponent. We said if in the parentheses what we see is multiplication or division, you get to take that outside exponent and make it go to everything. So this exponent is going to go to the 4, and it's also going to go to the 10 to the negative 2. So just to reiterate that, remember, if you have multiplication or division inside of your parentheses, you get to take that outside exponent and make it go to everything. So 4 to the 3rd power is 64. Again, I'm reviewing those properties of exponents. Power to a power, you keep your base, you multiply your powers. Negative 2 times 3 is negative 6. Now this looks pretty good, but 64 is too big. Remember that constant needs to be bigger than 1, smaller than 10. So I'm going to ignore my 10 to the negative 6, and I'm going to focus on 64. Where does the decimal point need to go? Well, it needs to go right here, right smack dab in the middle of the 6 and the 4. So I have 6.4, and now I need to figure out the exponent. My original number, 64, is big. It's bigger than 1. That means I need a positive exponent, and I only moved it 1 time. So I'm going to get a positive 1 right there. So I keep my 6.4, and then I look at 10 to the 1st times 10 to the negative 6. Again, multiplying, keep the base, add your exponents. So our exponent is going to be negative 5. And so that's going to be that final answer. Again, I'm going to encourage you to try this last one and then check on the website and check to see if you got those 3 problems that you're trying out on your own correct. I'm trying to remember what your homework assignment is, but honestly, it's real late and I have no idea. So whatever it is, do it please. Let me know if you have questions. You can go to the website, go to the blog, type in some questions. I'm trying to answer those as quickly as they're coming. Y'all let me know if you think that you would like to have a class time on Zoom. We can do that one day next week. I don't have a problem with that. It would be during your normal class time. So whatever that time period is for 6th period, that's when we would do it. But y'all let me know. Give me some feedback, because if nobody's giving me feedback, then I'll just keep doing this. And if you guys think you need some face-to-face time with me, we can do that. I have no problem. Hope you guys are having a better Saturday night than I am, and I will see you later.